Hi everyone. For this first video, I'll be explaining about separable differential equations. So without further ado, let's go to the first example. What do we have here? We have dy over dx equals to cosine of x over y squared. And what do we need to know before we start to solve this problem or this differential equation? In separable differential equation, we need to separate both variables, the x, and pair it up with the dx as well as the y and pair it up with the dy into each side and integrate it with respect to dy and dx and then make it into a y equals function. So we know that if we multiply y squared here into the left side and into both sides, we will get y squared dy equals to, and we know if we multiply dx in both sides also, we will get cosine of x dx. And from here on, we're safe to go. We just need to integrate it with respect to y of y squared and the integration of cosine x dx. This is a simple integration, so we all know what to do here. And for the right side, we have sine of x plus c, our constant. Here's the tip. You just need to add the constant into one side because adding the constants in both sides and adding them up together, constant plus constant will still be constant. So just put the constant into the right side. It's safer to do that. And for the next step, since we want to make it y equals function, we just need to multiply 3 into both sides and get rid of the 3 in the left side. And we still have the y to the third power here. We just need to cube root both sides, which makes the right side be 3 times sine of x plus c to the power of 1/3. And this is how you solve the first example. And one more thing, this solution is called as a general solution. Why is that? Because there is no initial value problems given, so you call this as a general solution. So now, let's move on to our second example. So here's our second example. We have x squared plus 83 times dy dx equals to x times y. We know that we need to move all of the x variables into one side and move the y variables into the other side, and pair the x's with the dx and pair the y with the dy. And in the end, we want to make this differential equation becomes a y equals equation. Okay, let's do our first step. Let's multiply both sides by 1 over x squared plus 83. We will do the same thing here. And so we will get dy over dx equals to xy over x squared plus 83. We know that we still have a y in the right side, so we can multiply both sides with 1 over y and multiply this one with 1 over y. And so we will get 1 over y dy over dx equals to x over x squared plus 83. And so in here, we can just multiply both sides by dx, which makes the equation becomes 1 over y dy equals to x over x squared plus 83 dx. And from here on, we're good to go. We're going to integrate both sides. So we're going to integrate this side. towards dx. For the left-hand side, we know what is 1 over y. The integration of 1 over y, it will become ln of ln y. For the right side, we can use either substitution or my prep or what I like to do usually is called a throwback method. It is similar with use substitution, but it's simpler for me. So for this side, I'm going to do throwback method, which I'm going to take the derivative of x squared. Sorry, this must be -1. We're going to take the derivative of the x squared plus 83. It's 2x. And we just cancel out the x's. And this will leave us with 1 over 2 ln x squared plus 83. But don't forget a plus c. There's plus c here. So we know that the integration of this is this, and we know the left side, it will just become ln of y, and the right side is 1 over 2 times ln of, don't forget the absolute values, because in differential equations, absolute values really matter. And I tell you why when we get to the next chapter. So we've got this equation, ln of y equals to 1 over 2 times ln of x squared plus 83 plus c. We know that we can move this half, or 1 over 2 times ln x squared plus 83, and make it like this one. Ln x squared plus 83, or of a half, plus c. And we can get rid both of these ln's with putting e into both sides. And plus c. We can cross out e and ln, and this will just give us with, or I would rather call it the square root of x squared plus 83 times e to the c. Because we know from here that e to the a plus b is equals to e to the a times e to the b. I think you all got that from your pre-calculus. And so moving forward, we can get rid of the absolute values on the left-hand side. And we know e to the c here, e to the constant will still be a constant. So our final equation will be y equals square root of x squared plus 83 times c, or c times x squared plus 83. And this is a general solution, and the solution you will get by solving this differential equation. Now let's move on to our third example, which is the initial value problem. We are here in our third example. So what do we have here? We have dy over dx is equals to y times cosine of x, and we have this initial value problem of y, x equals 0 here, or y to the y0 equals 6. So let's try to solve this differential equation first. So remember the first step, move all of the x and y into each sides and pair them up with dy and dx. And so in this equation, we will get 1 over y dy equals to cosine of x dx, and integrating both sides equals to the integration of cosine of x dx. This will give us a pretty simple equation here equals to the sine of x plus c. And don't forget to add constant on the right side here, because we will try to find a constant using this initial value problem, or IVP. So, like from the previous example, we're going to try to cross out the ln by adding e to both sides here, and plus c we can just put it like this one, because remember e to the a plus b is e to the a times e to the b. And so we can cross out this. Oh no, we cannot cross out this part. This part stays. We get y equals, and then on the right side e to the c here will still be a c, or a constant, e to the constant. Okay, so we will get constant times e to the sine of x. So do we stop here? No. Before, in the previous examples, we might have stopped here because we're looking for a general solution since an initial value it was not given. But now we're given this initial value for in order to find the c. So what we need to do is that we're trying to find the c. Let's plug in all of the x's with 0 and all of the y with 6. So 6 equals to c times e to the sine of 0. We know sine of 0 is 0, and e to the 0, anything to the power of 0 is 1. So we know here that c is equals to 6. And what do we need to do for our last step? Is just to plug in the c, or substituting the c with 6. And it will give us y equals to 6 times e to the power of sine of x. And this is our final answer. And what do we call this one with usually? It's not a general solution, but it's a particular solution, since it has an initial value at the start of our problem. And so that's it for today's examples for the separable differential equations.